and welcome to Fire Engineering's Training Minutes. My name is Paul Dansbach, and in this session we're going to talk about a building that most fire departments will have in their jurisdiction. The subject of today's Training Minutes session is a one-story building of ordinary construction. Well, actually, it's going to be hybrid construction, and you'll understand why as we get into the video. The front part of the building, which is the customer area of the building, has a wood raftered roof and exterior masonry walls. The back part of the building, which is primarily used as a storage space for the mercantile occupancy, has a steel frame truss. We're going to go inside and take a look at the features of that truss and some of the construction features of the building. Okay, we're inside. We're going to take a look at some of the conditions of the structure and some of the features of the structure that are going to be concerns to the fire service. The first thing we notice is that we have a wide open floor area. Again, the lack of interior columns tells us that the building is a truss. This space, the space created by the truss roof portion of the building, is approximately 60 feet by 75 feet wide. As you will notice, looking up towards the trusses are a steel frame truss. The top chord and the bottom chord of the steel frame truss are parallel. From the exterior of the structure, that's going to give the appearance that this building has a flat roof, when in fact, the structure of the roof is a steel frame truss. In one of our previous videos, we were in a structure that was vacant, and that was obvious by the wide open floor areas and the absence of stock and material. This building is an occupied structure, and the stock and material is what creates the fire load. A fire in this occupancy will affect the trusses almost immediately. The steel will begin to absorb the heat and be heated. As the steel is heated, as the fire continues, once the steel reaches its yield point, the trusses will begin to fail. As we observe from the exterior of the building has an overhead garage door. The size of the building, 60 feet by 75 feet, may lend itself to interior firefighting. Well, at least firefighting from the overhead door. Incident commanders must make the decision based upon the location and the extent of the fire as to whether or not to commit firefighting resources into the building or into the collapse zone. Application of a heavy caliber hose stream with good reach and penetration is possible. We have no ceiling in this occupancy that's going to obstruct the hose streams, and hose streams can be directed up to into the truss base, cool the steel, and prevent failure of the trusses. As we look across the building, we notice a storage loft is built into one end of the trusses. This storage loft is open and accessible to the floor below. This will allow application of a hose stream from the floor below or from the open overhead door. A stairway from another part of the building also provides access to the storage loft. Crews must make the decision: what is the most efficient way of applying a stream to a fire in a storage loft? Do we apply the stream from the floor below, where we have direct access because there are no construction features, walls or ceilings obstructing that truss loft? Or do we attempt to stretch a line up a narrow stairway and place the line in service from the truss loft? We're going to take a look at that narrow stairway, and then you can decide for yourself which is the most efficient and safe way to apply a hose stream. As we've discussed, there's a stairway that leads up to the storage loft in the truss area. This is the stairway. The stairway is accessible from another part of the building. The stairway is narrow and will require the crew to make a 90-degree turn to access and apply the hose stream up into the truss loft. That stretch is going to be a difficult stretch using a 2.5-inch hose line. Once the crew reaches the top of the stairway, they're going to need to make a 90-degree left-hand turn to operate the hose stream up into the storage loft. Again, you're going to need to make the decision which is the easier, safer, and more efficient hose stretch. Stretching up a narrow stairway, having to turn the line, or applying a hose stream from down below on the floor area. Up on the roof, we notice there are some skylights. The skylights provide an opportunity for some quick ventilation. Removal of the skylights will relieve the heat and products of combustion from inside the structure. Another feature of the roof is that the roof is basically flat. Remember, we described the steel trusses as a parallel chord. The absence of a peak or bow on this roof may lead firefighters to believe that this is not a truss roof. Prior knowledge, pre-planning, and building intelligence will help provide firefighters with the necessary information to understand the buildings within their jurisdiction. In this session of Training Minutes, we looked at a building that contained a steel frame truss roof. The top chord and the bottom chord are parallel, giving the appearance that the roof may in fact be a flat roof of wood joists. Be aware that there are many different types and forms of trusses out there. All forms of trusses create some significant and unique firefighting challenges and hazards. Firefighters must recognize all buildings and structures that contain truss roofs and fight the fires in a safe and efficient manner. Thanks for watching this session of Fire Engineering's Training Minutes.